Hello everyone. Today we will look into the properties of exponents. Here's our vocabulary. Exponent, the number that represents the amount of times the base is multiplied by itself. A base is a number that is multiplied by itself in an exponential expression or equation. A power is an expression that represents repeated multiplication of the same factor. Here is our first rule. It's called the product of powers property. When two like bases are multiplied together, you combine, add the exponents. So if you have a as the base and another a as the base, they are the like bases, they are multiplied together, then the result would be adding the exponents. In our example in here, when we have 4 to the third power and 4 to the second power, we would keep the base, like base, and add the exponents 3 plus 2, that would be equal to 4 to the fifth power. The reason why this works is that you will have 4 to the third power will be 4 times 4 times 4. And we also have 4 squared, which is 4 times 4. And at the end, you have 4s being multiplied together a total of 5 times. So for the fifth power. Here's your first you try. Here's our second rule. It's called power to a power property. If you have a value that's already in an exponent, and if you're raising to another exponent, then the new exponent can be found by multiplying the exponents. 5 to the second power to the fifth power would be found by multiplying the exponents. You would get 5 to the 10th power. The reason why this works is that when we have 5 to the second power to the fifth power, the exponent tells us the base has to be multiplied by itself 5 times. So we will take the base and multiply it by itself 5 times. By the first rule we learned, we could also add the exponents when base is same. So the bases are same, they are 5, and we can add the exponents 5 to the second power plus 2 plus 2 plus 2 and plus 2. This will be equal to 5 to the 10th power. Here's your second you try. This is our third rule, powers of a product property. Product is multiplication, and you have a multiplication in here, two different bases, and you have a power on top of the base. The way this works is that the power is going to affect everything that's inside of the parenthesis, and we would have a to the mth power times b to the mth power. Let's look at an example. We have 5x squared parenthesis to the fifth power. The exponent is going to apply to every term that's inside of the parenthesis, and we would have, by the way, this is 5 to the first power. We would have 5 to the first power to the fifth power. Also, we would have x squared to the fifth power. By the previous example we learned, we can multiply the exponents. 5 to the fifth power times x to the 10th power. Here's our third you try. Here's our next rule. It's exponential division property. When we divide powers with the same base, we would subtract exponents. On our example here, we have the same bases, and we will subtract exponents. 4 to the 11th power minus 5th power is equal to 4 to the 6th power. The reason why this works is that when we have 4 to the 11th power, this means 4 is being multiplied by itself 11 times. 7, 8, 9, 10, 11 times. And it's divided by for the fifth power. So we can simplify some of these. 5 of these and 5 of these can simplify. And at the end, we would only have 4 to the 6th power left. Here's your you try. This is our last rule for today, power of a quotient rule. When you have two numbers divided and it's raised to an exponent, the exponent is going to affect both the numerator and denominator, and we would write a to the nth power and b to the nth power. Here's our example. We will apply the exponent to both numerator and denominator. We would have negative 5 to the third power over y to the third power. Whenever a number is a small number, I recommend you evaluate the number. Negative 5 to the third power would be negative to 125 over y cubed. Here's our last you try. Here's an example using most of the properties all in one. We should start from inside of the parenthesis because there is a grouping symbol, and we should take care of inside the grouping before we do anything with the exponent. Inside of the grouping, we can see that there are exponents with the same base, and they are in division. So we can take care of that as the first step. We can do 4 over 5, and let's expand the x squared to x times x. Let's expand x to the fourth power as x times x times x. And we still have the to the third power. 2 of the x's on the numerator and 2 of the x's on the denominator will simplify. And we will have 4 over 5 times x squared to the third power. Next, we are going to apply the exponent both to numerator and to denominator. Our numerator would be 4 to the third power, and denominator would be 5x squared to the third power. I put the denominator into parentheses because there is more than one term. Now, numerator 4 to the third power means 4 times 4 times 4. Denominator still has a power on top of another power. So we are going to use this exponent and apply it to both of the terms that are in multiplication. 5 to the third power times x squared to the third power. Now we have a power to power property on the denominator as this time. 6 to 4 divided by 5 cubed is 5 times 5 times 5. And 2 to the x squared to the third power is going to be x to the sixth power. Whenever an exponent is small, we can actually solve it and evaluate it. Whenever an exponent is big, we can just leave it as an exponent. We are going to try to leave every exponent in as a positive exponent. That's pretty much it. Please bring any questions you might have to the class.